Welcome to the deep dive. Today we're jumping into something called Render Network, Picker's Render. It seems to sit right at this, well, kind of complex spot between massive 3D graphics, this whole decentralized thing, and, the crazy demand for AI computing power.
Yeah, it's a hot intersection. And that's really what our sources are digging into. Our goal today, break it all down. We've gone through a ton of material, and we want to pull out the core stuff for you, nice and simple. Because look, you really need to get why this matters. GPU power, that computing muscle, it's like the new oil. Seriously. And the old ways, the big cloud companies, they're getting slow or just way too expensive for most people, especially creators.
Right, so we're trying to give you the fast crack, the essential info on a network that's, well, it sounds like it's trying to build the future pipes for digital stuff, one frame at a time, but like decentralized.
Exactly. Let's dive in.
Okay, so let's start at the beginning. What's the actual problem Render is trying to fix? Like I hear graphics and AI, and I mostly just picture NVIDIA's stock chart going straight up. Where's the pain point for, say, an artist?
The core issue is really simple. It's cost and it's access. Getting your hands on enough high-end GPU power when you need it, that's tough. And demand is just exploding. You've got next-gen media, think super realistic games, VR, Hollywood-level effects, plus this AI tidal wave that needs tons of GPU power for training models.
Okay, so if I'm maybe like a freelance 3D artist or a small indie game studio, I need some serious computer horsepower to make my stuff look good. But I can't afford to just buy like a basement full of expensive graphics cards.
Exactly. That's the bind. Now, you could go to the big cloud providers, Amazon Web Services, Google Cloud. They rent out GPU power. But their systems are built for huge companies, really. The pricing gets prohibitive fast, especially if your work is project-based, kind of lumpy. You don't need it all the time. The sources we looked at, they consistently suggest Render Network aims to cut those costs dramatically. We're talking maybe 60% to 80% cheaper than using those traditional cloud services.
Whoa, okay, 60 to 80%.
Yeah.
That's a massive number. It almost sounds a bit too good to be true, doesn't it? Like, what's the catch? Am I getting slower renders or lower quality for that kind of discount?
That's definitely the balancing act, and yeah, we'll get into the quality side of things. But the fundamental idea here is about opening things up, democratizing access. It's about getting rid of that need for massive upfront cash for your own render farm or those killer monthly bills from the big cloud guys, making those, Hollywood level tools actually reachable for almost anyone.
Right, so how do they do it? This is where the core idea gets kind of cool. Instead of thinking of Render as one company selling time on its servers, think of it more like a huge, sprawling, decentralized co-op. Or the analogy that pops up a lot is like an Uber for computing power.
An Uber for computing power. Okay, I can picture that. Break that down for me.
Wow.
It's based on a really simple inefficiency, right? There's tons of powerful computing hardware, GPUs mostly, sitting idle all around the world. Think about your own computer. Maybe you have a decent graphics card. It's not working hard 24/7. It's like having an expensive car just sitting in the garage most of the time. Render basically connects you, the person with the idle GPU, they call you a node operator, with someone else, maybe halfway across the world, who desperately needs that power right now. They're the creator needing to render a scene or run some AI task.
Okay. So the whole point is to take all that wasted computing time, that idle power sitting in people's homes or offices, and turn it into something useful, and maybe let the owners earn some money from it.
Precisely. It creates this peer-to-peer marketplace, connects the people who need power, creators, with the people who have spare power, node operators. And the cool thing is, this creates this incredibly flexible system that can scale up or down almost instantly without anyone having to build giant, expensive new data centers.
That makes a lot of sense conceptually. But my first thought is trust. If I'm a creator, maybe working on something valuable, how do I trust some random person's computer, somewhere else, to handle my job correctly and securely? This isn't like delivering a pizza, right? It could be sensitive stuff.
Absolutely. Critical question. And that brings us right to how it actually works under the hood. The trust isn't just based on hoping for the best. It's built into the system using tech, specifically crypto and verification methods. Okay, so the whole process is managed by this pretty smart setup. It's kind of a hybrid system designed for speed, but also reliability, which you absolutely need for these kinds of jobs. Let's break it down into maybe 5 main steps, keeping it simple. First, job submission and payment. So the creator bundles up their task, sends it to the network. They pay using Render's own token, the Render token. Or, and this is really important for getting regular folks and pros on board, they can use something called RNDR credits.
RNDR credits, what are those?
Yeah, think of it like an easy button. You just pay with your credit card or PayPal, like normal online shopping.
Yeah.
The system handles the crypto stuff in the background. You, as the artist, might not even need to touch crypto directly.
Oh, that's smart. Yeah, hiding the crypto complexity is probably key if you want, like, actual creative professionals to use it, not just crypto people.
Totally. Okay, second, the burn and mint thing. They call it the burn and mint equilibrium or BME model. Sounds complicated, but the basic idea is this. When someone pays using those easy RNDR credits, the network automatically takes the equivalent value in Render tokens and burns them, destroys them, poof, gone.
Burns them. Why?
It does two things. One, it's a way to prove on the blockchain that the work was actually paid for with real money. Two, and this is the economic part, it links network usage directly to reducing the total supply of Render tokens. More usage, less supply. Theoretically, that makes the remaining tokens more valuable.
Huh. Okay, so paying in dollars tightens the token supply. Interesting.
Yeah.
What's next?
Third, task orchestration. Your big, complex render job. The network automatically chops it up into lots, sometimes thousands, of smaller pieces. Then it intelligently sends these little pieces out to the best available node operators across the globe to work on them all at the same time. Parallel processing. Fourth, proof and verification. So the node operators do the work, they render their little piece, but before the final result goes back to the creator, the network checks the work. There are mechanisms like watermarking and comparing outputs to make sure the job is done right, ensure quality, and prevent anyone from, cheating the system. They call it proof of render or POR.
Okay, quality control. Makes sense. And the last step.
Fifth, the reward. Once the work is verified and the creator says, yep, looks good, new render tokens are automatically minted, created, and paid out to the node operators who did the work. So you see the loop, credits get used, tokens get burned, work gets done, tokens get minted as rewards. It's designed to be this self-regulated cycle.
Got it. Now, I remember reading, didn't they switch blockchains? They moved from Ethereum to Solana last year, right? Why was that such a big deal? Isn't Ethereum like the standard for a lot of this stuff?
It is, but for this specific model, the BME thing, Ethereum had limitations. Remember how the job gets split into potentially thousands of tiny pieces, and each node operator needs to get paid a tiny amount? Doing thousands of tiny transactions constantly on Ethereum, it was becoming too slow and way too expensive because of transaction fees called gas fees. It would eat into the savings. Solana, on the other hand, is built for speed. The sources mention it can handle up to 65,000 transactions per second, and the cost per transaction is practically zero.
Wow, 65,000. Why so many? It's just one artist submitting one job, isn't it?
Yeah, but think about the orchestration. Sending out those thousands of subtasks, getting confirmations back, verifying each tiny piece, sending out thousands of micropayments. That's where the volume comes in. That kind of massive throughput and super low cost. It was basically essential to make the whole BME model work efficiently and actually deliver those big cost savings they promise.
Okay, so the cost savings are clear, and the peer-to-peer efficiency using Solana for speed. That makes sense. But let's go back to the quality and trust thing. If I'm like Pixar or a big visual effects house working on the next blockbuster, cost savings are nice, but quality and reliability are everything. My job depends on it. How does Render convince those kinds of high-stakes clients to trust a decentralized network of, random computers?
That's probably Render's biggest advantage, actually. It's what some of the sources call their Hollywood moat. And it comes down to their origins. Render wasn't just started by some random tech guys. It grew directly out of a company called OTOI. And OTO makes Octane Render, which is like the industry standard rendering software used by tons of professionals worldwide.
Ah, okay. So they weren't starting from scratch. They already had connections and credibility within the actual creative industry.
Exactly. Instant street cred. They had a built-in user base of professionals who already knew and trusted OTOI's technology. That's huge.
That's a serious head start.
And they didn't stop there. Look who's on their advisory board. We're talking huge names. J.J. Abrams, the director, check. Ari Emanuel, the CEO of Endeavor, basically one of the most powerful guys in entertainment, check. Even Dr. Eric Schmidt, the former CEO of Google. And Beeple, the digital artist who sold that NFT for millions. These aren't just names on paper. These people understand the industry and tech, and their involvement gives Render massive institutional legitimacy.
Okay, yeah, that's That's some serious firepower on the board.
And it's not just talk. They've proven the quality. You know that giant Las Vegas sphere? That massive LED ball?
Yeah, seeing the crazy videos.
The network was used to actually render some of those incredibly complex, super high-resolution visuals displayed on it. That's about as demanding a test as you can get. They also did work for immersive content on the Apple Vision Pro, specifically for an app called The Archive. So again, working with top-tier, demanding partners on cutting-edge projects.
Oh, rendering for the sphere. Okay, that definitely answers the quality question. But what about the security aspect, the intellectual property? If I'm a movie studio sending scenes from an unreleased film across this network, how do I know my stuff won't get leaked or stolen from some node operator's machine?
Super valid concern. Number one issue for studios. They use strong encryption, obviously, to protect the data while it's moving around, but the blockchain part adds another layer. They use on-chain tracking, basically creating a secure, verifiable history of the asset. It's called provenance. It means they can track exactly who created what, where it went, who worked on it. This kind of detailed, tamper-proof record is becoming really important, especially now with AI generating images and videos. It helps answer, who owns this? Is it original? That's a huge problem Render helps solve.
Okay, that's a pretty compelling picture. Hollywood roots, big names, proven projects, IP protection. But no system's perfect, right? Our sources must have highlighted some risks or criticisms. What are the main challenges Render is facing?
Yeah, definitely. The sources point to about three main areas of, let's say, tension or risk. First one is, ironically, centralization concerns.
Wait, centralization? Isn't the whole point that it's decentralized?
Well, yes and no. While the network is made up of distributed nodes, it still relies pretty heavily on OTOY's core technology, that Octane or Render software. They are working on integrating other software, like the open-source Blender cycles, which is good. But the perhaps bigger point is how new nodes join the network. It's often permissioned. You can't just download software and start earning instantly. You usually have to apply, maybe get on a wait list, get approved by the Render Foundation.
Ah. So it's not like Bitcoin mining where anyone can jump in. The foundation kind of controls who gets to provide the supply of computing power.
Pretty much. That gives them significant control. Now, the counter-argument you hear, and it's fair, is that for those high-end clients, like the Sphere guys, you need that level of quality control. You can't have unreliable nodes messing up a multi-million-dollar project. So they've arguably traded some decentralization purity for the professional-grade reliability that attracts those big fish. It's a trade-off.
Okay. A necessary compromise, maybe, to keep that Hollywood moat intact.
Yeah.
Makes sense. What else?
Competition. Big time. That's the second major risk. Competitive threat, especially from projects focused purely on AI. Render started with graphics, and it's expanding into AI, but it's running into fierce competition there. The name that comes up most is IO.net. They seem to be positioning themselves differently. IO.net is going almost all in on AI and machine learning compute. And they've been super aggressive in signing up nodes that have those really high-end specialized AI chips, the NVIDIA A100s and H100s, the super expensive ones that are amazing for training large AI models. Render has some of those. But IO.net seems to have gathered a much larger pool much faster, specifically targeting that massive AI training market.
So Render might own the niche for 3D artists and rendering, which it knows really well because of OTOY.
Yeah.
But it could be losing ground in the potentially much larger, more general AI compute race to players like IO.net who are laser-focused on just that.
That seems to be the emerging dynamic, yeah. It's a strategic challenge for Render. Can they compete effectively for those big AI training jobs while also serving their core creative market? And that ties into the third risk. Economic complexity. Remember that burn and mint token model, the BME?
Burn tokens when people pay, mint tokens as rewards.
It's a really interesting design, but its success, its long-term stability, hinges entirely on one thing: massive continuous network usage. For the model to actually create that deflationary pressure where more tokens are burned than minted, you need a ton of people constantly paying for rendering and compute jobs. That burn rate has to consistently beat the mint rate.
So if network usage slows down,
Yeah.
maybe because competition like IO.net takes a big chunk of the AI work, then the whole economic engine could sputter. The token might not become deflationary as hoped.
That's the core dependency. The sources suggest the BME model is still kind of proving itself out at scale. It relies on that growth curve continuing upward steeply. If adoption flattens or declines, the economic model faces real pressure. It's very sensitive to actual usage. #tech 6, summary and closing.
Wow, okay. That gives a really clear view. The strong Hollywood foundation, the cool tech, but also these real challenges with centralization trade-offs, fierce AI competition and that sensitive economic model. So if we had to boil Render Network down to just one or two sentences for someone listening, what's the key takeaway?
I'd say Render is this really interesting, proven marketplace born from Hollywood tech that connects unused computer power around the world to make high-end graphics and AI work much more affordable. It's basically trying to crowdsource a global supercomputer.
Right. And its future success really seems to hang on whether it can keep that high-quality Hollywood edge while also scaling up fast enough to grab a big piece of the AI pie from competitors, all while keeping that unique burn-and-mint engine running strong. It's a tricky balancing act. Yeah, this is a great point to quickly pause and remind our listeners of something.
That's right. If you're enjoying how we break down these complex projects into simple pieces and want more reviews just like this, make sure you subscribe to our channel, CryptoBox. We do all the complex research, so you don't have to. And just thinking about the big picture here, we've kind of established that GPUs, that computing power, it's like the fundamental resource for everything cool happening next. VR, AI, you name it.
Yeah. Which brings up a pretty interesting question for you, the listener, to chew on. Right now, the giant cloud companies, Amazon, Google, Microsoft, they kind of control the supply of the most powerful GPUs. So how much can these decentralized networks like Render really shake things up if they can actually convince enough regular people, enough small businesses to basically plug their own computers in and become part of this global distributed data center?
What does that idea mean to you? The idea of taking the power to create, the power to compute, and spreading it out from those few big players to potentially everyone.
Definitely something to think about. And that's it for this deep dive. Thanks for joining us.
We'll be back soon with more insights.